Without further ado, may I invite our first speaker, Dr. Jing, Director, Higher Singapore Innovation Center, Higher Open Partnership Ecosystem.
Hi, everyone. Nice to meet you. This is Jing. I'm the Director of Higher Singapore Innovation Center, Higher Open Partnership Ecosystem. We call it HOP. So first, I would like to thanks for the organizer, IPI Enterprise Singapore, to invite Higher to be the partner of this Sustainable Open Innovation Challenge platform. And I would like to take this opportunity to share with the community one of the challenge for packaging innovation. And we hope to find opportunity to work with you to reshape the cushioning materials. So the challenge is how to substitute EPS in home appliances packaging with sustainable cushioning materials. You know, Haier is a world-leading home appliance maker. As you can see in the top right, we use the EPS as the cushioning packaging materials to help us deliver the premium appliances to our clients in a perfect conditions. The 4 appliances, the image you can see here is courtesy from Hair's subsidiary company, one of the premium brands, Fisher and Paykel brand, Fisher and Paykel appliances. But you can see even the light one, the weight is 30 kg, and for the heavy one, like fridge or built-in oven, is even heavier. It could be 100 or up to 250 kg. So it needs a perfect cushioning material to provide the protection during the transportation and shipment. And EPS now take the job. Yeah, the performance is quite good, but sustainability is not good. It's not acceptable. So the EPS does not meet our sustainable packaging mission. Why? Let's see. We see the costs. If you only talk about the manufacturing of the EPS, because it's now so well adopted for maybe over 10 years or more than that, and it's not only used for the home appliances, electronics devices, it's also used in the cold chain and daily packaging. So the cost is quite reasonable. But if you talk about if you consider about the end-of-life treatment, disposal, recycling, landfill, especially in an environmental responsible way, the cost is quite high. And also there is detrimental gases discharge. And the raw materials, EPS can only be made from the non-renewable materials. This one is definitely not acceptable. So what's the desired outcome? Performance, yeah, we keep seeing the cushioning performance because it provides the protection not only for the appearance, it also protection for the functional parts, electronics, control, all these parts. And so we need the performance to matching or ideally exceeding EPS. EPS is lightweight, is 25 to 40 kg per cubic meter in the density, and it's a foaming materials. It's full of more than 98% of the air, so provided a very good cushioning performance. And the static and dynamic compressive strength, it can go through, can take this repeated impact resistance and shock absorption. So if we do the evaluation, we will do the like the drop down, like the lean testing, and to test the pressure from top, from bottom, from side. And also we need it to remain the dimensionally stable during global distribution. Because you know, during the transportation and shipment in the container, the temperature could be up to 70 Celsius degree. So we need to keep the thermal stability, and also we need it to be waterproof to protect all the components. And sustainability raw materials need to made from the renewable raw material like biomass that are environmentally responsible sourced. And recycling is very important, not only for the sustainable value, it also through this recycling, it can reduce the full life cycle cost. And commercially or home compostable, for example, when it in the commercial facilities, if we change the environment, it can be compostable. And we need it to have the low impacts on the greenhouse gas emission, water and energy consumption during the manufacturing and end of life process. Last but not least, economic viability, because the cost is very important, especially for this packaging industry, is so high volume and daily usage. And we understand for the early stage materials, new materials, the cost could be high, but we hope through the raw materials and manufacturing process, during these kinds of the feasibility study, we hope the materials could reach the reasonable price comparable with the EPS when it go for the commercial stage, the full commercial stage. And the raw material should be scalable and affordable. And for the fabrication of new materials is compatible with the existing manufacturing equipment, not only reduce the time to go to the market and also to reduce the OPEX. And ideally, both the sustainable raw materials can be sourced and also for the parts supplier are located close to Harris manufacturing site to minimize the transportation impacts. And this is some candidate materials we studied and we would share as a reference. So for example, this expanded PLA, we think this one is a potential candidate. It provides very good cushioning performance, lightweight, hydrophobic, but the material is very cost and the raw materials has the limited supply and regionally is more in North America, not in Asia. Another is the wood pulp. This one we also think is quite promising. We talked to some suppliers. It's biodegradable, renewable, and recyclable. And we see, as shown in the image, some supplier already make it for the laptop packaging, but the density is still quite high, limited density range, and more importantly, now is more for the lightweight loading. It's not ready for the heavy loading beyond 50 kg. And honeycomb board, yeah, like drywall, global supply, renewable, recyclable, but performance, the anisotropic performance is not good. And expanded PE, yeah, this one also very good performance, uniform density, but cost is very high, and also the end of life treatment recycling side is not good. So the business opportunities, as I mentioned, Fisher & Paykel Appliances, one of the premier brand of Haier Group, is leading the initiative and is willing to offer the direct application knowledge in the white goods domain, and as well as to drive the supplier and cross Haier Group to adopt these sustainable materials and move to a more sustainable supply. And for the commercial readiness, we want the TRL level of the solution should be 7 to 9, and at least has a prototype, the samples for testing. Ideally, already being used in some industry and willing to expand it to home appliances packaging. And solution development or pilot testing are expected to be finished within the next 12 months. And yeah, for the potential, you see, Haier Group actually, as a world leader home appliance maker, we have 7 brands and we have 122 factories globally, supply 160 country and regions. And the premier brands, yeah, we are already take more than 30% of the market share, and we will continue to grow this high-end market. So yeah, and the last one I want to share with you who is Higher Singapore Innovation Center and how we play our role in this community. So Higher Singapore Innovation Center is hub node connecting Singapore and regional, the local innovation community with Higher Group. Like this platform, we share the challenge and also we share the business opportunities. And we have the business units, global R&D centers, could be your partner to do the joint development, pilot testing, and contribute our domain knowledge and accelerate it to the market. And more than this sustainable challenge, we are also working on the sensors and materials and design to make their future life more healthy, comfortable, convenient, sustainable, and safe. Yeah, so if you have any solutions, yeah, feel free to contact us or contact IPI. Thank you.
Thank you, Dr. Jiang, for that presentation. And now we're going to spend a few minutes for our Q&A segment with the questions that's presented or posed by our viewers on our Pigeonhole platform. The first question that I'd like to share with you is, it was mentioned in the problem statement that the proposed material should be compatible with existing EPS manufacturing equipment. How open would the Higher be to working with other types of cushioning material, such as sustainable, flexible foams or lightweight, high-performance 3D printed components fabricated using sustainable materials?
Okay, yeah, thank you. I assume this question from SimTech, right? I think I got the email for these inquiries. Yeah, I'm currently ready to reply for that. So for the manufacturing, since the 3D printing, the concern is whether it can be scaled up and to meet the volume, because these kinds of the packaging materials is tons, 100 tons of their consumption. If you consider the whole Higher Group, I think it's more than 100 tons of the consumption. And if we use 3D printing, first cost, second, yeah, the volume, whether it can meet up these kinds of requirements. If they see these kinds of 3D printing materials could be scaled up to meet these volume requirements within, for example, next 2 to 3 years, I think, yes, definitely, I think we are open to evaluate. But if they don't know, maybe 4 years or even more than that, then maybe not is the right time to review that.
Okay, thank you. We have one more question for you. Can you provide more information on the service cycle the new material needs to undergo? For example, average loads of the equipment, the materials needs to withstand, average thickness used for the current packaging, and other examples.
Okay, so for thickness, I think you can imagine, I think everyone buy the new appliances, right? You can imagine what's their thickness. So maybe, let's see, 20 centimeter or 10 centimeter, yeah, like this. But the density, I think I write in the problem statements, the density, yeah, the lightweight, because for this one, the foam material, existing EPS foam materials, or other new sustainable like PLA foaming. So if the foaming materials then can make their similar foaming, or I see, for example, the air, these kinds of things. So means the first is the performance for the to take the shock or take these kinds of the pressure or compression. And another thing is, yeah, lightweight is because of the this one is for the most case for the shipment, when you do the shipment, then appliances is already very heavy, and we need these packaging materials to provide the protection, but don't add the extra weight. And also, when we do the shipment of these kinds of the material, the foaming materials, also the weight is the shipment cost, because again, it's a big volume usage and daily usage. Yeah, that's also why we ask the manufacturing should be close nearby the home appliance manufacturers. Otherwise, we also need to consider the shipment transportation cost. This is what's the existing packaging industry. Yeah.
Okay. Thank you very much, Dr. Jiang, for your presentation. Of course,
Yeah.
we just had Dr. Jing from Higher Open Partnership Ecosystem. Thank you so much.
Thank you.